This is practice exam for Unit 1. Unit 1, this test, it contains a Chapter 1, Chapter 2 in AP Chemistry. The content is a chemical foundation and atoms, molecules, and ions. Okay. Number 1. And then this test, I split into two video. One is a multiple choice, and the other one is a free response. Okay. So let's do multiple choice. Number 1. How many sig figures should be retained in the result of the following calculation? I have another video for sig figures. So if you're not familiar with the sig figures, you can watch the other video. And this one is a 3 sig figure. This one 4 sig figure. And this one 1, 2, 3, 4, 5, 6, 7 sig figures. And this leading zeros doesn't count, only this one. So you have a 3 sig figures. Okay, you should be able to tell how many sig figures each one. And another rules for mathematical operation for sig figures, when you multiply or divide, then you have to follow least sig figures. Okay, least sig figures is 3 basically. So answer B. Okay, when you multiply or add, when you multiply or divide, then you have to follow the least sig figures. Number 2, recommended other dose of oxalisyphilin, a drug used to treat asthma, is 6 milligram per kilogram of body mass. Okay. Now calculate dose in milligrams for 200 pound person. Okay, so this one is a dimensional analysis. So you're gonna start with a 200 pound. Okay, so what they're saying is for 1 pound they give you this unit conversion. So it's a 1 pound 453.59 gram. So pound cancel, so you end up with a gram so far. But they ask you how many dose in milligram. So what I need to do using this one, I need to convert to this body weight to kilogram. So times 1 kilogram, we know that 1,000 gram. So far body weight is this much kilogram, and then now you multiply this. So 1 kilogram, you need to have a 6.00 milligram of those. Okay, so this cancel out, and then you end up with how many milligram dose you're gonna need. So 200 times 453.59 times 6. Now divide by 1,000. So I got 544.308 milligram of those, right, for 200 pound person. So closest one is a B. Okay. This one, when you talk about sig figure, how many sig figure you're gonna have, then those are given on is like 3 sig figure, right? That one is also 3 sig figure because you have a dot there. Okay, so your final answer is only 3 sig figure. So you look at here, that's less than 5, so then you drop it. So 544 milligram is a final answer, but closest one is answer B. Number 3, which of the following choices consist of a pair of isotope? Isotope means it should be same element, so it cannot be different element. Either this or this or this should be same element. Only difference between those two different element is, I'm talking about these two element, like example, their only neutron, okay, number of neutron will be different, which means their mass also will be different. Okay, that's the only thing difference. So if you see answer, this one should be C, because that's the mass, right? Mass is a 2 gram and this is 1 gram. Okay. But the other one is this is a math here. So 23 same, 23 same. So that doesn't show the neutron is different. So isotope, this one only number of neutrons different. Okay, which means mass number, right? Mass number also different because math consists of number of protons plus number of neutrons. Okay, number of proton is same as their atomic number. So atomic number not gonna change it, right? So only number of neutron will be different. So C is only their mass is different. That means that's a different isotope. The other one 35 same math, and sodium also for B, sodium 23 also same. So that's not pair of isotope. Only C is isotope. Number 4, the following data were collected for several compounds of nitrogen and oxygen. Compound WXYZ, and you have the other column, if you look at here, is a mass of oxygen that reacted with 1,000 grams of nitrogen. So basically, this one, if you look at the number, you have to realize this one times 2 will be this one. So let's practice. 0.5711 times 2 is next one. And then also 0.5711 times approximately 4, let's see. Then that's exactly this. Okay, this one is also, so let me rewrite. So this one 0.5711 times 2. Okay, this one 0.5711 times 4. Okay, and this one, let's see, 2.855 divided by 0.5711. So that's approximately 5. So 0.5711 times 5. So this one shows multiple, right? The x is twice of the multiple, and so this one shows basically 1 gram of nitrogen, and mass of oxygen is different. So let's say this one is nitrogen like NO, and this one twice of the oxygen mass, so NO2, and this one is NO4, NO5, things like that. So what is this? This is a law of multiple proportion. Okay, that is law of multiple proportion. Hess's law we're gonna learn a little later chapter. The other one doesn't make sense, so it should be this one, multiple law of multiple proportion. So let me write the definition of this. This one basically when two elements combine with each other, when two elements combine each other to form more than one compound. Like example, more than one compound. The weight of one element. The weight of one element that combined with a fixed weight. Combined with a fixed weight of the other. That are in a ratio. They are in proportion. Proportionally combined, right? So twice and 4 times and 5 times like that. So that's the law of proportion. Let's move on. Number 5. Of the following, only what is a chemical reaction? So they checking, chemical reaction, and or maybe it's just a physical reaction. Physical reaction, like melting. This one, lead itself, it's not gonna change it, right? This lead itself is not gonna change it by melting. So then that's not chemical. Dissolving sugar, that's not chemical. So that's also physical change. And oxidizing silver, yes, that's basically chemical reaction, right? Oxidizing, so it combined with the oxygen. Now, crushing a stone, that's a physically changed. So answer should be C for that one. Now, next one, number 6. How many molecules of CH4 are in 48.2 gram of this compound? How many molecules? So you need to know this one also, Avogadro numbers. So which is a 6.02 times 10 to the 23 molecules, right? In 1 mole. Okay, that's what we call Avogadro numbers. I believe you know that already. Now, so how many molecules is CH4? So you start with a 48.2 gram of CH4 times, so 1 mole. How many grams of CH4? So you have to compute using your periodic table. CH4 C is a 12.01 and H is 1.01. Okay, that's the one I have. It could be a little different, depends on what periodic table you use, but mostly so those are like averaging mass. That's why it's a little different, depends on periodic table you use, but it should be very close. So your CH4 math, molecular mass is at 12.01 plus 4 times 1.01. So if you compute 1 plus 4 times 1.01, I got 16.05 gram. Okay, 16.05 gram of CH4. Now question is how many molecules? So so far I have a how many moles, right? CH4. Now 1 mole, you have Avogadro molecules, right? So 6.02 times 10 to the 23 molecules, right? I'm doing dimension analysis. So now this mole cancel, so you have how many molecules so far? So 48.2 times 6.02. Some book uses 6.022 times 10 to the 23rd, but I don't think that matters anyway, because you can use the answer choices, which one is the closest, times 10 to the 23rd and divide by 16.05. So I got around 1.81 times 10 to the 24th molecules, which is D. Okay, so you can use a dimensional analysis to answer this. Now number 7, consider the reaction. They gave you this reaction, this arrow right here. Okay, so zinc sulfide and oxygen, and now zinc oxide, and you have it's a SO2, right? So then now what you can do is which value is closest to mass of this one. When 50.0 gram zinc sulfide is heated on open vessel until no further weight loss is observed. So this one, what you have to do is, also I'm going to use a dimensional analysis. Okay, so you start from 50.0 gram zinc sulfide times, so I need to know how many mole of this one. So they gave you zinc sulfide is a 97 gram, right? So one mole of zinc sulfide is 97 gram of zinc sulfide times, so they gave you ratio, okay? Sometimes they don't give you completed this chemical equation, then you can find out the coefficient of that one, but this one they already gave it to you, so you can just use it. So two, this one, 2 zinc sulfide and 2 zinc oxide, right? That's our interest, right? You need to know how many math, what is the math of the zinc oxide you have, right? So using that one, so you can put molar ratio. So far, this gram zinc sulfide and mole of zinc sulfide, this is mole, cancel out. So how many grams? So 1 mole of zinc oxide, they gave you 81 gram, right? 81 gram of zinc oxide. So now just you need to multiply then, right? Numbers, so let's do that. 50 times 2 times 81 divided by 97 divided by 2. So I got 41, that's approximately 41.75 gram. So closest one is a B. Okay, so multiple choice, you have to find the closest. And then which one of the following species has exactly as many electrons as it has neutrons? Okay, let's talk about it. Like I said earlier, so that one is your math. Okay, so this one is and then H is a 1, right? H is a mass number is 1. So the atomic number is 1 for hydrogen, and then mass is a 1. So that means you have here basically 1 proton, right? And 1 electron, and you have a 0 neutron. Okay, I'm talking about the hydrogen, A. Now second one, mass is a 40 for calcium. Calcium, if you look at periodic table, mass is a 40, and their atomic number is a 20. So your 20 proton number, remember, atomic number same as number of proton. That's same as in if it is not ionized, that's same as number of electron. Okay, but if it's ionized, then you have to think about it. Okay, and then another one is atomic mass is a number of proton plus number of neutron. Remember that. So this one, atomic number is a 20 for calcium. So proton is a 20, and electron, if it's not here, this one 2 plus, then you're gonna have a 20. But 2 plus means you lost the 2 electron, right? Then you have only 18 electron. And then 20 plus 20 is a 40, so 20 neutron you have. So let's talk about everything, and then we'll find out answer. C, carbon is atomic number 6, so 6 proton, and there's it's not ionized, so also 6 electron, and 14 minus 6 is 8 neutron. Okay, now the last one here, so fluorine is 19. Their atomic number is a 9, right? Atomic number 9, so that means 9 proton. And this one, it gained 1 electron, so 10 electron. And 19 minus 9 is a 10 neutron. Okay, so that's what that is. Now, it said exactly as many electron as a neutron. So then you see that that one is the same. So answer D is right answer. Okay. Now let's move on number 9. A 10-gram piece of metal is submerged into the graduate cylinder, initially containing 20 milliliter of the water. And then with the metal in cylinder, the level of water is a liquid 21.4. So the situation is a graduate cylinder here, graduate cylinder. So there's a water, and then you submerge a piece of metal, right? Some piece of metal you submerge, and then it'll go a little higher, right? So this one used to be 20. Now here is a 21.40 milliliter. So that shows that difference is the volume of that metal, right? So 21.40 minus 20 is 1.2, right? So that's a 1.2. Hold on, 21, 20. Yeah, 1.4, right? 1.4. 1.4 milliliter. That's how much volume increase by putting in. They ask you, what is if you look at here, their density, right? You see that density? So density is mass over volume. Mass is a 10, so 10 gram over volume is a 1.4 milliliter, right? So let's print the calculator. 10 divided by 1.4. I got around 7.14. So it should be zinc then, right? That's the closest one. Okay, so that's how you're gonna find out their density. Mass over volume. Okay. Number 10. How many moles of oxygens are required to oxidize 1 mole of CH3, CH2, COH according to the reaction represented below? Okay. So this one, the other one earlier, they gave you full chemical equation, but this one is they don't give you the coefficient, so you have to figure it out. So let's start from here. Always start from carbon. Carbon you have 1. Oh no, not 1. So actually 2, 3. You have 3 carbon, right? So then you can use that 3 carbon. So I'm gonna put it here. So 3, right? That's how you're gonna start. Let's say you have 1. And then anyway, this is 1 mole of this. So you have to start from there. So 1 mole of that, on the right hand side, you have to have that 3 mole of CO2. Now, let's talk about H, right? Hydrogen. Hydrogen, you have here 3, and this one 5 and 6 total, right? So 6 hydrogen. So to have a 6, this is already 2. So 2 times a what is a 6, right? So 3. So far we found out that one. Now let's talk about then how many oxygen you have. Oxygen you have 1, 2, right? Only 2 oxygen. And here, let's see. I know I have a feeling this one you have to have a fraction. This one 2 times 3 is a 6, and this one 3, right? So this is a you have 9, right? 9 oxygen. Now, so in here, left hand side, you have 2 plus something oxygen is a 9. So you have to have here 7, right? But I'm gonna make 7, so this one should be then 7 over 2. So 7 over 2 times 2 is a 7. That's the reason. Okay. So the coefficient of that is 7 over 2. Number 10, D. Okay, that's what you have to do. Number 11, what is the correct name for Cu3PO4 So this one is a polyatomic. Polyatomic, I believe your teacher provide you the table. So that one is a phosphate. Okay, that's a phosphate. We don't have this. So phosphate. Now, phosphate is basically PO4 3 minus. So this one 2 means 3 minus times 2 means negative 6 charge. So this one, that means you have a 3 copper, right? 3 times what will be negative 6? I mean positive 6 basically to be neutralized. So should be 2. So answer is a C. And also it shows you what is that charge right here, right? So charge is right here. Oops, that's gonna be charge is right here for Cu. Okay, Cu2. That's what that meant. But you can check. So one more time. Let me put that here. So PO4 is a 3 minus, right? 3 minus. So 3 minus and then but you have 2 of them. So charge is a negative 6. So entire the molecule, you have a 0 charge. Net charge is a 0. So you have to have a 6, okay? Then you have a 3 molecule of UCU, right? Copper. So each one is then 2 plus, right? Cu 2 plus. So that means this one shows you charge, right? So second. Okay, that's how you're gonna do. Now when chlorine gas react with the lithium bromide, so chlorine gas, Cl2, chlorine gas, fluorine gas, and bromine gas, then make sure you put 2, okay? It cannot be just on one element. It should be Cl2 plus lithium bromide. So lithium bromide, okay? Lithium bromide. When you combine, it'll, so that one should be then lithium chloride plus bromine. So bromine also should be 2. So let's those are gas state, right? Now, so then let's see. Then you have a Cl2, so you have to put 2 Cl, and you have to put 2 here, right? So then, yeah, then it'll be correct equation, chemical equation. So what happened is when you put Cl2 plus 2 at IBr, then it'll replace, okay? Instead of Br, it'll replace because it has a higher activity, okay? So if you look at your halogen is a F, fluorine, Cl, bromide, ion, iodine, like that, and then this one has a stronger activity. So which means when you put, let's say in this case, like you put Cl2 in the at IBr, it'll single replacement, so it'll replace because it's a higher, stronger activity characteristic, right? So it'll replace, then you get this. Now, so then which product you will have at ICl, right? Lithium chloride you're gonna have. Br2, then that's correct. Br2, but not Br. Okay, so that should be answer. Number 13, which of the following alkaline earth metal? What is alkaline earth metal? That's a group 2, right? Group 2, so 2A. So that's the alkaline earth metal. 1A is alkali metal. Greatest percent by math oxygen. So oxygen percent math, which one is greatest? So let's see. This one, beryllium oxide is PeO, right? And then this is a group 2. So yeah, so Pe2 plus and then O2 minus. So that charge is 0, right? So BeO and magnesium oxide, MgO also. Calcium oxide like that, and barium, so PaO also. So all of them like that. And then which one you think is a greatest percent math oxygen? Not the other one. Oxygen is the greatest. what is the percent mass? Percent mass is so example like here. What is the percent mass O, right? In beryllium oxide. So mass of beryllium is 9.01. So let me write down. So this one, molecular mass. Beryllium is a 9.01 in my table. 9.01 plus 16. Oxygen is a 16, so you add up. So that's a 2501. So what is the percent mass of oxygen? 25.01, and on the numerator 16 times 100. So they will give you that one. So let's calculate it. Okay, so then 16 divided by 25.01 times 100. So I got approximately 64% of percent mass oxygen. And I'm not going to do every single one, but the magnesium oxide, magnesium in my table, 2431. So 24.31 plus 16, 31 plus 16, you will have 40.31. So 16 over 43.31 times 100 will give you approximately like 40%. Okay, so if you keep going, you will see as you go down, those are higher mass, right? Beryllium is the least molecular mass. So in other words, in terms of percent mass oxygen, if it's the least molecular mass, then you're gonna have greatest percent mass oxygen. So answer should be A. Okay, so you can just do the rest of it and then you compare, and then which one has bigger greatest percent mass oxygen, then you're gonna get that one. So okay, this one is also O, oxygen in the second one. That's what I'm saying. Okay, now number 14. Given the information below, determine the weighted average atomic mass. Okay, so this is a good example how you're gonna compute that isotope, right? And then their average mass. So what you have to do is this one here, 0.10 times 218, and next one 0.15 times 220, and this one 0.75 times 221, and then you add all of them. Okay, so 0.1 times 218 plus 0.15 times 220 plus 0.75 times 221. I got, when you add up, 220.55. So that's approximately C. Okay, that's how I'm gonna see that. So example, let's say you have like carbon, right? Carbon, your mass is a 12.01, and your atomic number is a 6. So this is a math. Where this math coming from? That one is basically all the isotope. Okay, all the isotope, their average math. Then you get this one in periodic table. So this using isotope, also X is math is a 20 to 20.5, and then I don't know what this X is here, whatever that amount, you have that atomic number there. Okay, so percent mass, that's how you're gonna calculate it in isotope. Number 15. Next one. That's the last one basically. 1 mass of the aluminum sulfide is produced when 3 moles of aluminum react with the excess sulfur. So this is a limiting reactant. This one is excess reactant. So always you have to start with a limiting reactant. Excess means you have a lot of sulfur in this reaction. So what you start with, 3 mole of aluminum, okay, and you start with that. Now, so question is, what mass of aluminum sulfide? This one here, right? And then they give you a molar ratio. So 1 mole of aluminum, you have, 2 mole of aluminum is 1 mole of aluminum sulfide. Okay, and then your math is 1 mole of then aluminum sulfide. So you need to find out the molar mass of that. So what is the molar mass of aluminum sulfide, right? So aluminum in my table, let's see, aluminum 26.98 times 2 plus 3 times sulfide is 32.07. So let's calculate it. 26.98 times 2 plus 3 times 32.07. So I got molar mass of the aluminum sulfide is 150.17 gram. So 150.17 gram. Okay, so then you multiply. So that times 3 and divide by 2. So I got 225 gram around. Okay. All right, so then you can use your dimension analysis for that. So that's it for this video. And then I'm gonna upload for unit 1 exam for free response next.